Thank you for attending today's webinar. So today, as mentioned earlier, we want to check more various application of MIDAS civil. So we are going to make the three different type of the structure, starting from the 2D steel formwork. Formwork is temporary structure to support dead loads and the construction loads until the concrete has certain stiffness. In this example, we will see how to generate the 2D steel formwork to resist this tunnel concrete. And we will also check the analysis and the design for this formwork. This is the section property for the formwork. So all different type of the section will be defined and assigned as shown in this figure. Also, for considering the loading, in this model, concrete will be poured 3 times. It will be divided into 3 times. So starting from this bottom part, concrete will be poured for these parts first. When the concrete is poured, for considering this dead load and the construction load, 4 different type of the loading will be entered. 2 loads for the vertical and 2 loads for the lateral load. So the vibration and the impact loads in the vertical direction and also concrete dead load will be considered. In the lateral direction, which is this transverse direction, we will consider similarly the vibration and impact load and also lateral concrete placement loading. These 4 sets will be considered similarly for the second concrete placement, which will be applied to the area shown here. So for this area, second concrete will be poured and the similar loading will be applied. And finally, for entire area, concrete loading will be considered. Normally, in order to consider this sequence, construction stage analysis can be used, and MIDAS Civil has full functionality for this function. But in order to make model more easily, instead of using the construction stage, we will simply divide the loading for the 3 different placement loading. And then using the envelope load combination, we are going to compare the results. So let's try to make the model and check the results for this 2D formwork. For this structure, as you can see, this is the 2D structure. And we need to specify the structure type as the X and Z plane. And then we are going to define the material and section. I have predefined the material. So definition of material is very simple. We can specify the value directly here, or we can specify the desired standard from the list. And same for the section. So for each of the section, we can specify the value of the section dimension, or if we want to use the database section, we can simply select it from the list. So all different 9 section has been already defined with the I shape or the pipe, and all the size has been entered from here. Now we are going to make the model. Normally we have the plane in the AutoCAD file. So what I'm going to do is we are going to import the AutoCAD file. we can specify the desired section property and material, and OK. So this 2D model has been generated, and we want to assign the proper section property as shown in this figure. Each of the parts has different size of the section, so assigning the different section in MIDAS is also very simple. What we need to do is selecting the element, and then if we simply drag and drop, that will be assigned just like this. I will assign for each of the parts one by one. For this main part, I'm going to assign the section number 6. So select the desired part and then assign it. That's all. Similarly, for this part, I can assign the jack. And then for the braces, like this part, I can assign this H section. And for this top part, and these two as well, I'm going to assign the different H section. And for the other braces in lower and upper part, similarly, we can select them. And then I will assign the section number 1. So that's it. So desired section has been assigned, as you can see from here. After assigning the desired section, now I'm going to specify the boundary condition. For the boundary condition, firstly, we want to restrain the bottom. So we are going to define the support. This is the 2D structure, so only X and Z direction needs to be restrained. And for braces, for this nodal connectivity, I want to consider the moment release. So for this element, I can go to the P-band release, and we can release the moment. I want to release the I-end moment and apply. You can see the small dots in this part. And for this element as well, I want to release the moment. So P-band release has been applied. And similarly for the jack, which is this part, I want to make them as the pin condition. So I will release the moment for both ends. So it has been applied. So P-band release can be used. It can be very useful when you want to consider the truss, or when you want to consider release certain moment for the sub members. Now we want to specify the loading. Before going to the loading, let me change the unit, and we are going to move to the loading. For making the loading, first of all, we can specify the different loading in different load case. So different load case has been already defined. We are going to define the self-weight first. Program already know the weight density of the structure and its size. So I can simply enter -1, then self-weight will be considered. And now we are going to define the construction loads and the concrete dead load. For that, we want to specify desired element one by one. First, dead load will be applied for these three elements at each bottom. So I can specify desired element, and we can enter the loading in the global z direction, and the value will be minus 6.251. Once I click apply, the loading will be applied as shown here. Similarly, for these elements, I want to specify the one dead loads of the concrete. So different load case has been defined and specify desired value for the self-weight of the dead load, concrete, and applied. And force load case, I want to specify lateral load for these elements in the global x direction, and loading value will be 2.501 and apply. Similarly for these, the other direction, so minus value will be applied, and you can see it here. And fifth load, I want to consider the concrete pressure load in the lateral direction. Specify my elements again and enter the value. Same for the other parts, and with the minus value again. Once we apply the loading, so you can see each applied loading from here. For the vertical load, which was the working and impact load, and concrete dead load, and then lateral load, which is for the vibration and impact again, and the lateral concrete placement loading. This was the one set for the first placement, and the second placement, concrete will be poured up to here. So we are going to select these elements this time. So specify desired element again. The other part as well. And then we can enter. Specify the correct load case. And we are going to enter the global z direction. This is again the vibration and impact load in the vertical direction. And this time the concrete dead load. So change the corresponding load case and the value. And then enter the lateral load, which is vibration and impact again, using the load case number 8. And it will be applied to the global x direction again with the value 2.501. And the other part, this part, with the minus value. And next, second load placement loading for the concrete in the lateral direction. So I can specify the different value for the load case number 9, which is 180. Apply, and also for this part as well, I can enter the same value with the different direction. So just delete the minus value and apply. So second placement loading has been all applied with these 4 sets. So second placement for the vibration and impact, concrete dead load, and lateral load, vibration and impact, and the concrete placement load in the lateral direction. These were the second placement loading. Finally, for the third placement loading, we can specify element again, and we're going to enter the similar loading using the element beam loads. For easier selection, even we can use this option. So I will just exclude some of the element which is not required. So I selected this part, and then we are going to enter the vertical load for the vibration and the impact, same value as the previous stage. And next, the dead loads for the concrete, and samely the vertical direction. At this time, the lateral load. Specify the direction as global X, and same position, we're going to enter the placement loading for the concrete, which is the value 118. Also select the desired parts for this. And minus value. And also for the vibration and impact load. Okay. Finally, if we see the work tree, we can see all the loading has been defined as desired. Now we want to specify the load combination. So what I'm going to do is we can specify the load combination for the first placement. And this one will have the first placement loading, which is load case from 2 to 5, and load case 1 was the self-weight. And secondly, second placement loading, and similarly, dead load will be applied, and then from this loading, load case number 6 to 9. And third placement, dead load will be always applied, and then 10 to 13. After selecting like this, we want to have the envelope for the load combination I just generated. So we can select the combinations. So most critical combination, critical results among these 3 combinations can be checked. We are going to perform analysis and check the results. For checking the results, MIDAS provides all the checking results in the model view or table format. Firstly, let's try to check the reactions. For first placement loading, we can check the reaction from here. Value can be also checked from here, and also for the second placement and then third placement. If we want to check the detail value, we can go to the table. And let me select the combinations. For each of the combination, we can check the reaction value from here. And we can also check the deformation. For the envelope effect, we want to check the deformation. So as you can see from here, So we specify the envelope combination and even deformed shape, or without deformed shape is the only contours. And this deformation can be checked, and the maximum and minimum deformation node position can be verified. So for this element number 1, which is the bottommost, these parts have the maximum deformation. Also, we can check the forces, like the beam diagram. For the envelope effect, let's try to check the axial force diagram. And for the moment, so this diagram can also be checked. After that, finally, we want to perform design, steel code checking. MIDAS provides different type of the code, like the American or European, BS, Indian, and Asian codes. We're going to use the Eurocode in this model. So once we perform the steel code checking, the program will verify each of the elements, and these checking results can be shown. So detailed verification can be checked from here, like firstly, the member force can be checked, and then axial resistance, bending, and the combined resistance, shear resistance can be shown here. If some of the elements are not satisfied, they will be shown as this red color, and we can see which parts are not satisfied. Also, MIDAS provides very detailed design report in this text format. So if we want to verify more details, like firstly, the section property and the classification of the section as per the Eurocode, whether it will be the plastic section or elastic section, and axial resistance verification. Also, the shear resistance verification can be shown here. And what is the resistance and what is the member force, and their ratio can be shown. So which part is not satisfied, we can verify from here. Also, for the calculation of the resistance, we can verify detailed value from here, and all the value used here can be shown also upper parts. So MIDAS will give you all the calculation results with each of the value. Lateral torsional buckling can also be verified for the H section. So you can see this lateral torsional buckling results. And finally, the combined effect. So both sectional resistance and the buckling resistance can be verified and shown in this report. So it does the application for the steel framework, and let's move to the next application,